Hello, Penguin. Okay, so I am getting started. Okay. Okay, I have a frozen can of Coke sitting in the sink waiting to explode. Maybe I'll try to see what I can salvage from it. Hmm. Oh, Kik has a chat API now. Post chat message, delete chat message. Where's the WebSocket stuff? You damn fools. Where is the WebSocket stuff? Events introduction. Webhooks. Bro. 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 have they done? How have they made no progress in years? The fucking chat API, man. Where is it? Disappointing. Disappointing, man. Just disappointing. Okay, so give me a sec. I'll go fetch my Coke. Hey Donna. Okay, I have my frozen Coca-Cola. Let's go. But I think I did a good job of salvaging it. It's not completely flat, so yeah. I say this was a successful recovery from the original blunder. So I hope everybody is doing fine. Uh let's see what's on social media. Is this your framework? You mean Ziggy? I wouldn't call it framework because it's in the same way that you wouldn't call JSON a framework. It's a JSON alternative. So it's a data serialization language that I'm working on, and it has more syntax than JSON. But the syntax that it does have, I believe, is beneficial, and it has a better schema language. Oh, because the API. Well, yeah, it's API messages. You know what I'm noticing? There is no red anymore in the color scheme. I think I fucked up. I think we need a reddish color in here. Everything is perfect except the name. It's a ripoff. Well, the name is not really a ripoff in the sense that it is, or rather, if you will, it's a celebration of another ripoff because the syntax is heavily inspired by Zig syntax. So it's called Ziggy because it kind of looks like writing Zig. So do you want this because it's faster, more maintainable? I would say no, or rather, I don't know, maybe maintainable, yes. Although definitely not in the short term because um, I'm still working on this. So right now, I make there's bugs and I introduce changes, breaking changes potentially, but um But I would say that you want to do this. For example, if you ever found yourself annoyed at the fact that there is no built-in way of expressing tagged unions in JSON, this could be for you. If you wanted enums, this could be for you. Um, if you like to see a distinction, so this is JSON. If you would like to see a distinction between when a object has a key value mapping where the keys are defined by a schema versus when the keys are entirely up to the user, then you might want to use Ziggy. You can see it here in this example. So in Ziggy, there are two styles of key value containers. One kind is structs, and the other one is dictionaries. This is a dictionary. This is a struct. Oh shit, I have this typo here. This parenthesis should be down here. I need to fix this website. But I have two different types of containers. Why? They semantically, mechanically, they are the same. They're key value pairs. Nothing changes. But when you are reading something like a config file, it tells you right away when something is part of a schema. So the fields are fixed. They have meaning versus the fields are entirely up to you. So in this example here, we have a message we have a message that contains a payload. The payload can be this is a tagged union, so it's the payload is of type command, but it could be of something else. And command contains a struct, so a command must have in it sender, roles. These are necessary. Do, but then in extra, you can put whatever you want because extra is not it doesn't have a schema defined by the application, so you can stuff whatever you want in there. It's essentially like a place for you, the user, to stuff your own information in. And so there is different notation so that you can in the blink of an eye notice which is which. Coincidentally, Ziggy is also a superset of JSON, so you can use you can load a JSON file as a Ziggy, and a JSON document is essentially a Ziggy map that contains maybe also other Ziggy maps. Dictionaries, I should say. Dictionaries. It contains Ziggy dictionaries, and then you can upgrade this stuff to a struct as you start improving things. Why does some start with a dot and some do not? Because this is a struct and this is a map. The key value style inside them is different. And then I also have tooling that helps you with this stuff. So for example, here, I wonder why I use this style. I should put, right, I cannot put a trading comma also. That is sad. So foo.ziggy. Oh, look, I already have it. Okay. The auto formatter needs trading commas to do. Okay, so we have this. The auto formatter helps you turn these things into well-typed Ziggy stuff. For example, here, repository, I give a dot, but this now is an external container of type struct, but the field style inside is wrong. So I just write so that I can use format on save, and the formatter will automatically change the field style. So it helps you upgrade your documents, or also downgrade if you want. In any case, it helps you switch from one thing to the other. So that's the idea. That's one thing. Then there's a schema language which is not implemented in the thing itself, and then there's tooling. In any case, if you go to the website, you can read all the explanations as to why things are this way. Let's see. Sorry if this question has been asked many times. When does Zig intend to freeze the language spec? Well, first of all, we need to have a spec. We don't have a spec at the moment. So first we need to stop changing the language. Then we need to start writing a spec, which, will probably have some tweaks in the language and back and forth. And then after that, then you can start talking about freezing the spec, but it's going to be a while still. A few years. Did AI design the website? No, this website is pre-AI. I do not use AI to make my websites. I also do not use AI to make my software. Languages do have breaking changes, I thought. They do, yes. I don't know how that's handled. Major versions, maybe. Correct. Not necessarily, though. Um, you do not have to bump the major version of your language if you make a breaking change. Um, because, or rather, you don't necessarily have to do that for this reason. You can stay at your, let's say V1, you can stay at major version 1 for as long as you have a way to correctly compile all their code written before your breaking change. For example, Rust has introduced over time a bajillion breaking changes to the language, and they are still a V1 language. The way they do it is by having additions. When you create a package like a crate, I think it's a crate level thing. I might be wrong, but in any case, when you write a project, you specify essentially which version of the language, which edition of the language you want. And so older versions, older stuff that has been pinned to a given version of the language will keep compiling that way. And then in the meantime, as you write newer stuff that requires a newer version of the language, you request that edition. And each compilation unit, each crate, which will be built according to whatever semantics, and then everything works out. There are limits to this approach because I believe that they can change the language this way, but they cannot change the standard library. They cannot give different copies of the standard library to different modules, because different crates, because they still have to interoperate. Like they will potentially pass around vectors, hash maps, and whatnot. So you upgrading the standard library, I believe, is a lot more problematic. They can essentially, yeah, it's additive. They can add stuff, but they cannot remove stuff or break stuff. Can you tell me how to import from previous directory? I can't split my files into separate folders importing each other. Adding a separate module import in build a Zig doesn't work for Zig test. It works for Zig build though. Hmm. The way it works is that you can import from other directories and you can also go up, but your root file needs to be at the root. So you need to have an approach like you need to have inside your source file, you need to have like a root.zig or a main.zig, which is your entry point to your module. And then everything else needs to be either at the same level or below this root file. So, so for example, here, json.zig can go up and import check.zig. It can also go up and import ast.zig if it wants. So this is always possible. The thing that you cannot do is go above your root file, the root file of your module. So just make sure to structure your project in a way where you do this. No, imports are not relative to the base directory. They are not. you will see, like for JSON to be able to import AST, JSON has to write import dot dot slash dot dot slash ast.zig. So they are not relative to that. They are still relative from where you are, but you cannot go above the root source file. As for Zig test, be aware that once you start using Zig build, you need to stop using Zig test. You need to make a test step for your build script. If you want to know how to use the build system and see slightly more complex and full-fledged project, see how it's supposed to be structured, create a new directory, go in there and enter the empty directory and do Zig init. Zig init will create a default project for you where you will see in the build script how to set up a test step, how to do everything. That should help you get started with the main things when it comes to creating an application, like a Zig application. Have you tried C3 at all? I have not tried C3. I am not interested in C3. Frankly, I am not interested in any of the stuff that is affiliated with that splinter of the handmade community. I feel like I'm kind of done with the handmade community. Not in its entirety, but I'm definitely done with that splinter of the handmade community. So all in all, I mean, do I have anything concrete to say about the language, bad or good? I don't, because I said I haven't used it. But the thing is, I'm not interested in either C3 or Odin because I'm used to the Zig build system. Like I'm used to not just because I know how to use this thing and then I don't want to learn something else. My point is, I'm used to the luxury of being able to clone a project on any computer, run Zig build, and then it works. I'm used to go into my projects and have a release step. In the release step, compiles my project for Arch 64 Linux, Arch 64 macOS Linux, x86 64 macOS. Actually, this one is going away, so we're gonna have to kill it. But then also statically linked Linux, x86 64 Windows, Arch 64 Windows, and also WebAssembly. It's not part of these. Actually, where's WebAssembly, man? Oh, it's just not listed there. I guess it's below. Yeah. And then I also make a WebAssembly build of everything. It's just that WebAssembly is slightly different, so it has its own section. If your language does not have a build system and the capability to deeply integrate with C dependencies, I'm not going back. Like, to me, it would be a gigantic downgrade. Like my software, like, I mean, and I'm not like making this as like a general statement. The things that I'm able to do with my software today would be severely impacted by that regression. So, no, thank you. I'm not going back. So, yeah. But then I will admit that I'm also kind of done from a social perspective. I don't want to interact with Christopher Lerno. I don't want to interact with Ginger Bill. I'm good, thank you. They can go do their own thing somewhere else. I wish them the best. I wish them endless happiness somewhere else. So okay, I think it's time to start. What are we doing today? So let me recap what we did yesterday. Yesterday, we fuzzed my Zig implementation a lot, and we found a few crashes, which we fixed. I believe I ended the stream with no more crashes. Now, we have not we have not fuzzed everything. Hello, Shubham. We have not fuzzed everything. There is still a lot of code that we have not thoroughly fuzzed. So I'm not claiming that our stuff is crash free, but we certainly have fixed all the most like egregious stuff. So what is my next step? Yesterday I tried the LSP, and I also found it having issues. I fixed the issues. I think that some of the issues were related to flow. I think there might be a bug in flow, which next time that I find Neurosite, I'll mention it to him. Or rather, I'll ask him to double check, because I don't have an easy repro on hand, and this is just a suspicion, which I think he should be able to corroborate easily by reading the source code. So I fixed those. And one feature that was just not working was autocomplete. So turns out that I had completely regressed autocomplete. I literally had in the LSP source code a if true return here up top. So I was essentially commenting out all the code below. I fixed it. I have not re-implemented everything yet, but I've implemented the basics still. And so we also have some autocomplete. One thing that we can do is push the autocomplete a little bit more further, which is one thing that would be nice to do. The second thing is that I want to work on today is finally schema validation for Zig types. So people are generally used to this idea that when you define a schema, let's say that you have a JSON schema, then you have a tool that automatically generates a type definition for you based on that schema. That is not wrong. That is a feature that I also want to have, but I don't want it to work exactly that way. I want something better. I want a system that can be used in the Zig build system. So it's gonna be like a step in the build pipeline, where basically we test a user provided type. So you provide a type definition, and we test it against the schema. And here's the nuance. The idea is that your type will have extra fields that are useful at runtime, but that should not, for example, be serialized. So these are fields that you can add to your types that are defined that are going to be skipped by the serializer and deserializer. Then you can have your own custom methods. Then maybe you can have opinionated takes on how you want things to be typed in your thing. I'll give you an example. You define a type that in the Zig schema is defined as having a list of tags. Your type in Zig maybe doesn't have a slice of strings, a slice of tags. Maybe it has an array of 3 tags. So your type essentially adds a restriction. It can only have up to 3 tags. Now, that is a type that is unable to deserialize arbitrary documents, but it is a type that is guaranteed to, but it is a type that can serialize to that type of document correctly. It will always generate documents that have 3 or fewer tags. It cannot generate one that has multiple tags, but you don't care, right? It's still correct. So that is a type that can correctly serialize, but that cannot deserialize. And that is fine, because there are some types that are, like, if you're on the receiving end of a file format, if you're on the producing end, then it is fine for you to have extra restrictions. Now, you could argue that maybe we should have maybe the schema language should say this, that the array has maximum 3. But I don't know. My point is, I want this to be something that doesn't just generate types, but that it is able to validate existing types so that you can extend them and you can add fields that only exist at runtime. Because I've been doing this a lot, and it is useful. And I guess you can always wrap your data into an outer thing, or rather, I mean, yes, you can do it, but there's compromises, the performance compromises that you might have to do if you do that. So I want to give you the tools to essentially guarantee schema compatibility, but also extend your types with runtime fields that are going to help you make more, write more efficient code. That's the idea. Let's see. A little out of the loop. What's the handmade community, which I presume Ginger Bill and Learn belong to? Search for handmade network, and you can start learning about them if you want. It's it was a community of people that like to, as the name implies, right? They like writing software from scratch. They do lower level programming. They tend to be game development. They tend to be close to game development, video game development, although not entirely. But people that make video games, they are the ones who have you can expect to have a high sensibility towards writing efficient code, that kind of stuff. But then stuff happened, and the community splintered into, I think, like two chunks and a half, and I don't know, weird shit. Weird shit. When we'll see you building your own LLMs in Zig? Me? By the LLMs, you mean like an inference engine? I don't think I will anytime soon. JSON schema types, isn't that what GraphQL tried to do? No, that's like, just search JSON schema. JSON schema is a file format. It exists. It's used a lot. Like if you use VS Code understands JSON schema. It's a file format that is incredibly horrible to read as a human, but JSON schemas exist. When do you get a typing feedback? Compiler on time in the editor linter, all of the above? Well, ideally comp time and editor linter. So, but the editor linter stuff already exists. So for example, so here I have repro.ziggy. I can go to definition. Oh, let me delete this. I can go to, okay, I choose the one example that is not correct. So I go to definition on Mango, and you can see that here I'm in a file with the same name, but it's Ziggy schema. And here I define the schema where I say, okay, the top level element is foo, and foo is a struct that contains apple, banana, mango, and Zig. Apple is a boolean, banana is an int, mango is a string, Zig is a dictionary of arrays of float. So I go back and I can do, I press a dot and do I autocomplete, and it tells me which fields I'm missing. I can go here and do space K. Wait, Mango doesn't have anything. Let me add apple. I do space K, and it shows me the doc comment from here. Expensive computers, blah blah. So I go back, space K, and it shows me expensive computers, blah blah. And if I add foo, it complains unknown field. And if I have a second apple, it tells me duplicate field. So you get the idea. I'm afraid of anti-AI woke. First we want to ban AI, then we want to ban the internet, then what? Electricity? Anti-AI woke? Oh my god, man. You do whatever you want, man. Like, you want to use AI, go use AI. I sometimes use AI myself. I just don't want to use AI to make my websites or to make my software. I heard the Handmaid's series. Yeah, there we go. Okay, so so the way it works is that the way it happened, as far as I remember slash know, um, is that Handmaid Hero started, which I also followed, by the way, when it started many years ago, right? A lot of people liked Handmaid Hero so much that they started, I don't know how it started precisely, like a forum or something. Was Discord already a thing? Maybe. So they started a Discord. In any case, they started congregating one way or another. And from there, the Handmaid Network community started. They run conferences. They had like a game jams, that kind of stuff. And yeah, that went on for a while. Then one way of looking at it, which is, by the way, opinionated, so you might want to, take what I'm about to say with a grain of salt. That's my opinion, and I'm also giving it to you in a short and simplified manner. Um, Basically, what happened is that as as the community grew, Casey didn't want to have anything to do with it anymore. Partially because Casey and Jonathan Blow are annoying as fuck, especially Jonathan. Casey, I think it's more normal, but they are both kind of annoying sometimes. So, what happened is that then the community had this split in it where uh, they some people felt like they were being abandoned by their god. Like they felt like they had strayed away from the light of God. The fact that they were not getting Casey and Jonathan to really talk to them anymore was like a moral failure of the community. Like, like literally when the god abandons you, that kind of stuff. So while some other people said, no, you know what, these people, especially John, are kind of ass, so it's fine if they don't want to do that anymore. And so essentially this was the split between the people that really like to look up to these guys. They really like to kiss ass, yeah, I think, in a sense. Like they really have, in my opinion, these deep need to have somebody that they consider of higher moral stature than them to look up to. And so, long story short, stuff happened, and a little bit of Game of Thrones happened as well, and the community split up. um so I don't know exactly what's going on there anymore. And I think the whole thing, like the reason why I stopped being like involved with the community there is because ultimately on a personal level, I'm annoyed at these social groups that on paper should be pushing forward for improvements in the software industry, but then fall incredibly short when it comes to the practical stuff, and that reduces their effectiveness. I just feel like that the Handmade Network has failed the check to be effective, because you have now the group of people, the Jonathan Blow friendly people who are now they fucked off, and now they're doing their own thing, but they're elitist, as you can imagine. They all use Jai, which is not open source, and so they're not really gonna make any difference going forward. The other ones that remain, in my opinion, have really failed hard at recognizing what's going on. So, in any case, again, sorry, I'm saying a lot of things in an imprecise manner. There's a lot more nuance. There's a lot of good people in that community that do not deserve to be spoken ill of. So let's make this clear. But I have to prioritize things that I expect will make a bigger impact. Also, even professionally, like given what I do at the Z Software Foundation, we have to keep riding the wave, and we literally do not have time to stop and do things that are not effective. So yeah. Yeah, I think that. Okay, let's set aside Jonathan Blow. I think I don't know. To me, Jonathan is the Andrew Tate of software development at this point. So I'm really not interested in what he has to say anymore. But for Casey, I don't know. Like he has his pet peeves. Like he has it out for object-oriented programming. I don't think he's wrong. But like, for example, he recently had this like 2 hour long talk about the history of object-oriented programming, where his entire point during the full talk was, look, check out how I was always right on hating on OOP for these historical reasons. I'm like, fine, dude, whatever. And I want to say, I agree on most points that he makes about how OP is detrimental to software development. I do seriously believe that. About that talk, it's I mean, if you look at it in an uncritical manner, maybe you can even find it interesting because it's historical and whatnot. But if you understand that what his point is and how his perspective is necessarily going to skew the way he presents things, I don't know. I think it's 2 hours of wasted life, in my opinion. So, whatever. Okay, you know what? Enough. Let's stop talking about this stuff. Let's actually do things. Let's make a difference. So, this is my LSP. I showed you that it tells you when you make a wrong syntax. It tells you when you have duplicate fields, missing fields, and whatnot. So, this is where you have your first line of defense in your editor. Why is this useful? This is useful because if you're modifying a configuration file, you want to be told, right? You want to be told what are your options here, and you want to be told, okay, what is field supposed to do? And the answer is banana, banana, banana. Well, but sometimes the answer can be more interesting. So this is one use case covered. Next is there's also, by the way, CLI tooling. There's Ziggy check. Ziggy check will test a Ziggy document against a schema. Now, this is complaining because of the syntax errors. So let's save. Because I modified it, but it didn't save. And now you see it says missing schema. Schema missing field banana. So it tells us who's Casey. Search for. Well, actually, if you search both names, you will find right away. But the full name is Casey Muratori. Okay. So we have all of this. Let's now implement a Zig build system function that takes from you a Zig module, a professor is not a professor, let's write this build step that validates stuff for us. Let's go. So how do we do this? I think Ziggy needs to gain a build directory at this point. So we have a little bit of garbage in here. This is garbage. This is garbage. These are garbage. These are like things that are not going to commit, files that I'm just playing around with. Also, we need to commit these changes. Okay, let's commit these changes. Git status source. Sorry, git add source. So let me just quickly see what we did in here. So we unbroke the language server. Change the offset. Yeah, it's mostly language server. GPG. GP. Okay. So Ziggy, Let's create a directory called build, and we put this stuff in there. So build will have maybe checker, schema checker, type checker. Oh, type checker, I like. Type checker.zig. Underscore. Type checker.zig. I think this is it. Then the build script will have a function. It will expose a function that you can use, I guess. So Ziggy has a CLI, so I can call it as a process. Oh yeah, of course. Absolutely. And it has all the goodies. Formatting, querying, which is not implemented yet, but you know, it's supposed to be kind of like JQ. It's on the pile of to-dos. Schema checking absolutely works. Or rather, there's some complicated schema checking stuff that is not implemented yet, but the main functionality is there. File document conversion. This is not implemented. Actually, I've implemented JSON. I think also YAML, but then I regressed it. So this right now is in a bit of a shaky situation. But you know, obviously, it needs to be able to convert between file formats. And then you have the good old language server. Yeah. Yeah, JQ is pretty cool. But you know what is the insane thing about JQ? Why is it a third-party tool? Why does none of these file formats have any official tool that does all of this at the very least, right? It's kind of insane that is the case. Anyway, so type checker. Let's go into the build system. Now this is gonna be funky because we need to test a Zig type, and then we need essentially we need a how can I say? We need a system for communicating what the stuff should be. So we'll see. So pub function. And actually, this should maybe go even above build. Pub function add the type check step. You will see me trying to figure this out in a moment. So cd build step. B is gonna be. Oh, I don't know if I can call this B though. I shouldn't, because that's not our B. That's the user B. Let's call these actually, what do I call this guy? Where do I have this? Zine has this. What do I call this stuff? Project. I called it project. You know what? I'll continue the project lineage. Okay. So you give me your build script. Then you give me a module. Give me a module. And the idea is that your module needs to have something in a shape that we expect at the root level, essentially in the root file. That's the idea. Do you give me a full module, or do you give me, no, you cannot give me just a source file because you yourself might have dependencies. So you need to set that stuff up yourself. Just give me a module. Okay. And then in here, what we do is we add an exe. So b dot. This is not add executable. This is also where's b? It's project. Uh, there's only add executable. I guess as long as I don't install it, it's fine. Oh, this is so dumb. So add executable creates an executable, but essentially, but de facto, you only publish it if you install it. This stuff needs to be reworked, I think. Root source file. B dot what? We don't have B. What's the magic function for getting B? Gimme B. Dependency from build Zig. That doesn't give us, that gives us a dependency. So our B is in depth builder, which is a pointer. Perfect. Okay. So this is going to be zinb dot path build slash type check dot zig. Okay. Oh, you probably need to give me also target and optimize. Yeah, you need to give me target and optimize. Yes. And then we need to add modules. Oh, also, what am I doing here? Okay. Can we do that off of ZNB? I hope that is not a problem. We can do this off of project. Okay. Then, yeah, so check root module. Then, check.root module at import. So there are two imports that we put, that we give there, which are important. One is the user type stuff. What do we call this? Types. And that's going to be your module. And then we add Ziggy. Also, I called it Zine app, Ziggy app. Okay, so our thing will have types in Ziggy. So type checker. Oh, type checker. I hate the lower case dash. Okay. What do we do in type checker? So we are gonna have types. We're gonna have Ziggy. We're gonna have STD. Library. Okay. Pub function main. Uh, Actually, maybe without the exclamation mark, we need to control. We need to be precise with how we error out. So now our goal here is to test fully provided types. So we look at all decals in types, and we expect them to work correctly. Do we expect it to have only one decal? Also, against which schema? Wait a second. We also need to know which schema. Huh. Um, so how do we say that a type should respect a given schema? How do we say that a type must respect a given schema? So we could in a build system have you specify that, but then that means that you can only like one invocation will type checking only one type at a time, and I don't think that is a good idea. I think that it is a better idea to essentially do everything at once. Um, we can have the type itself advertise that to us. So we expect every type to have in them a uh, a string that corresponds to the schema. That seems about right to me. So let's do it like this. Decals is going to be at type info types dot struct for just call it info. Sorry, info for info dot decal names, comma info dot decal types. Actually, is there decal types? I don't even know. I think not. You grab that with field, right? Actually, maybe I'm wrong. Info. I'll just try decal types. I mean, because I don't remember. So decal names. Name and ty for type. So what do we do? Does it have a Ziggy decal in it? So if not has decal, ty, comma, Ziggy, we complain. Now, here's the interesting thing. What type of complaint do we make? I think it should be a compile error. Because it cannot be the thing is we're doing everything at comp time no matter what. So even if we put these, if we turn this into a panic, there's no equal types. Okay. Um so if we turn it into a panic, essentially it's gonna become um a program that is hard coded to just panic. So we might as well make it a compile error. Like it's just the same effect, it just happens earlier. Although there is one important thing. The compile error the compile error will show us I think it will show us like a stack trace. We don't really want to show users stack traces. We just want to show them a good looking error message. So we want panics after all. Well, not panics, sorry. We want fatal essentially. Um, we probably want a function to report error. So the error is going to be what? Is every error connected to a type? Yeah. Oh, we could make this uppercase T. That also works. So we could have error type, then comp time fmt string args no return. Oh no, you know what? We make this void and we turn this into info. And then fatal, or rather error. Or maybe this is error and the other one is fatal. Let's do info and then fatal. So fatal is going to be T type. It's essentially the same signature. But it's no return. And internally, it does um, okay. So what do we do in info? std debug the print. Uh, validation failure. You know what? I think this needs to be multi-line. So validation failure for type S. Okay, so let's just get some error message going. It doesn't matter if it's not like super super genius. And you know what? Never mind. We don't even need the multi-line stuff. Like this. Okay, so if it doesn't have the Ziggy decal, then we oops, this is called info also. Wait, when did I not rename this? Fatal. Fatal. Um T, and the error message is gonna be has missing missing Ziggy decal. Then um missing or private. I think has decal returns um false even if the decal is private. Then so it needs to have Ziggy. Then needs to have, instead of Ziggy, it needs to have schema. Q. What's Q? Oh, quoted. Does it do more than just quoting? Like, does it like escape stuff? Okay. So Ziggy schema. Then with Ziggy schema, um, then we need to pass Ziggy schema to we need to build the schema. So const ast equals ziggy.schema.ast init. Um, we need an arena, so let's do it like this. We need IO. Actually, you know what? We might not even need any fucking IO here. Let's fucking go. GPA t.ziggy.schema. Uh, uh, Catch. Uh, oh, wait a second. We kind of wish we could do try. No, let's do try. That's fine. This is a starting point. Okay, try this. Then we say if ast.errors.len is greater than 0, fatal, t schema contains errors. And actually, we don't even have to do this. Let me think about it for 1 second. Well, we cannot do fatal, that's for sure. I think the way we do it, does schema AST have something like meta? I don't think it does, but yeah, no, it doesn't. Um, how are we supposed to print errors? What's the good way of printing errors? Do they have format? Do we format them one after the other? Yeah, we keep formatting them one after the other. Oh, so I never implemented the like a more full fledged error printing thing. Okay, okay. Um, so debug print. think it should be colon, then line, column, then and then the error message. I think it's error. The format only prints the tag, right? It doesn't do anything much more than that. Yes. Main location. Some of these have payloads, which gets printed automatically. Okay, so main location is going to be lock. Do we have a get selection on lock? We have slice. We have a get selection, which is good. We do this outside. It probably wants source, I'm guessing. Let's see the Ziggy dot schema. Okay. So with this, we print all the errors. And if there was any error, then we fatal t virgula t comma aborting schema contains errors aborting. Need error after the cell stuff too? Oh, you're right. Okay. So with this, we have parsed the AST, and we know that the AST doesn't contain any error, so it can be used. What we need now is something that checks that it works out. So it needs one more. Yeah, thank you. Okay. Let's see how far we go with this. We can try to run this and see it complain about stuff. It doesn't do any checking yet, but it's a starting point. One thing that we should do is in the build script we should specify a little bit more. Let's call it types. Um, validates user provided types against Ziggy schemas. Types is a module that must whose root source file must only contain public declarations that encode of types of, of container types that are meant to be used with Ziggy. Okay. If targeting master change SCD built into SCD lang. Yeah, I've already seen this change. Oh, you mean this one? This guy here. Optimize mode is not under built-in anymore. No, no, this stuff is still here. You're talking about reflection stuff, right? Okay. Then why is this resolving? No, okay, flow is kind of pooping itself, but it's an alias. Mm-hmm. Okay. So I think this is a reasonable explanation. Okay, I think I gave all the hints that I could. I just used the XCC for some Win32C development on Linux. I can't believe that it just works out of the box. Yeah, it indeed does. I mean, if you get into more complicated stuff, um, dependencies on Windows and whatnot, you will have to do some work. It's not a magic bullet where everything automatically falls into your lap. But for, let's say, system dependencies, yeah, pretty much. Also, if you're looking for Zig bindings to the Win32 APIs, there's Zig Win32 by Jonathan Marler, which are programmatically generated uh, from the official Microsoft stuff. So, like, if you're fine with just defining your own extern definitions, then more power to you. But if you at any point in time need more, heavyweight integration, then check that stuff out. Okay. So far so good. We need something that tests this stuff. And intriguingly, we have this stuff. So this is under schema. How do we deal with this in the build script? Path join test Ziggy. Test Ziggy. Oh, wait, I do not have any schema tests? I'm not running schema tests. That is interesting. So, how do we do this? mkdir type checker. And in here, we create a directory per test case. Or do we create a bunch of files and then we just loop over the .zig files? I think directories are cleaner. So let's do one that is like simple. I'm going to have type.zig, or let's call it root.zig. Then I have schema.ziggy, root.ziggy schema. And then we'll create the snapshot output in here. These are snapshot tests. So root ziggy schema is going to have struct root has a bool b u32 int c bytes. Okay, so this is our simple example. Then in root.zig, we have pub const foo1 or root1. Say that this one is okay. What is this stuff supposed to be? A bool, B U32. That's actually not correct because that is a signed number. So again, there's a distinction between being a producer and being a consumer. Being a consumer, it's more restrictive. Being a producer, it's more lax. And we need to make a distinction. I'm not doing this yet, but I think at some point, I think that the schema, like schema role, should be either producer, consumer, or both. Like you decide which role you take, and that is how we test for validation. ABC, either that or we start giving these, or we change Ziggy and we make Ziggy have these type information. But man, uh, I don't know how much I want to complicate the Ziggy schema, so we'll see. C instead is going to be a array of, actually, you know what? Let's do, right. C is going to be a consuate. Okay, so there's one. Now this needs pubconst Ziggy. And then this needs pubconst schema, embed file, root.ziggy schema. Perfect. Okay, so this is our type definition. And what we want is to have, this is going to be a root OK. And then there's going to be a root error 1. Where this is going to be U32. This is going to be bool. Let's have one success, one fail. So actually, we can even call them just even simpler, just OK and error 1. You know what? Let's keep the root prefix. I think that might make it less confusing in error messages. Okay, so we have this. Now we need the snapshot test to know that it needs to loop over these directories, for which we only have one now, simple. And it needs to invoke our executable, run it, and then we diff and create the snapshot test. Okay, so frankly, we can probably copy this and see how much of this we need. Type checker. So type checker is going to be tests schema type checker schema type checker base path. Then we open it to iterate. Inside the directory, we see another directory, we skip. If we see a file that starts with a dot, we skip. Actually, that doesn't even have to be like this. In there, what we want is something simpler. We want root.zig, and then we want wait, why are we creating a bajillion of these guys? I hope that there is a .zig file in these test directories because, yeah, but we make a module out of it, right? Yeah, of course we do, necessarily so. Okay, so also, if this is directory continue, wait a second. We go into the checker. We grab directories. I would say if it's different than directory, we skip. Then we get the base name. Here we're doing the executable creation, which we don't need to do because we have a dedicated step for it. Type module name is going to be base path. Base name.zig. This is going to be no. They all they are all going to have the same name. It's going to be root.zig, and that creates a module. Then we call add type check step. Oh, the problem is that this is going to try to call this is going to try to dependency from build Zig. Does it? But this is not going to find, this is not going to give us ourselves, is it? This is really going to search only our dependencies. Fuck. Fuck. I guess we can make an internal step. So the internal version, the internal version has B. Okay. Project Ziggy B. We don't need the Ziggy dep. We do need the Ziggy module though. Okay, there are a few things that I need to fix. Return add type check step internal project. Shit, the Ziggy dep thing was actually useful. I should not have completely nuked it because I just needed to move it. Project Ziggy B. See the module Ziggy and types. Okay, so this stays as it is. This goes private. This is missing the run step. Run out artifact. And we return this. Okay, so this is now correct. Now we can go back here and we can say, okay, so we have the type module. All these types. Add type check internal BB. What else does it want? BB. Frankly, we only need Zigbee for this. We could change this to a lazy path. You know what? Yeah. It looks like it's still Bluetooth. Turn it into a lazy path. Okay, so it's gonna be only one B. Actually, this should go here though if you do it like this. Okay. Do I have a Ziggy module in here? I have the CLI XZ. Oh, there's a Ziggy module up here. Okay. Okay. So we don't add anything here. Then add run artifact that's already here. We don't need to give it any argument. No need for an argument. Um, we expect a. Oh, what do we expect actually? Ah, God damn it! There is no. Doesn't matter if it succeeds or fails. Mm, I expect exit code one. Sure, all of them should have a failure case in them. Fine. Capture STDR. Write it as snap. Snap name is format entry.name. That's the base name. Update snap update source file base path snap name. No. No. This is base name, comma, snapshot. Okay. I think this is well, we're gonna have a bunch of programming errors, so we're gonna have to go through some compile errors. But this should be some good snapshot testing going on here. Let's see. I'm gonna keep this directory open in a tab because we might need to go in there and see what's broken after we fix these problems. Build. Missing field name in add executable. Oh, huh. Bro, I genuinely do not know. Well, I guess we can call it type checker without any formatting. I guess collisions are not going to be a problem since we don't install this stuff. No field or memory function. Expect exit code in build step. Oh shit. Oh, this is nice. Okay, so this returns a run step. Okay, so here we return the run step. But from out here, we return dot step. So these returns just the public API just returns a build step that you can depend on, but you cannot fuck around with it. Yeah, you cannot fuck around with it, while we can fuck around with it. Okay, let's see how we're doing. Incompatible types come time in and resolved offset. Testing expect equal. Oh, oh. So I broke tests and I didn't run tests and oops. Yeah, so this is mentioned in this. Oops. God damn it, man. Okay, hopefully we're good. The Zig inspires me to build a custom visualized language where everything is based on types. Mm-hmm. Oh god, it's optional. It's optional. Well, for now, we do this. Okay, now we are only erroring out for the type stuff. Unable to resolve comp time value. In line 4, my dude. No field of error function format in schema SC error. Are you joking? It's the Is it the list of errors? No. No, it cannot be. Oh, it's the tag that has format. Okay, that makes sense. Process exited with code 0, expected exited with code 1. That is correct. Let's go break our example. Let's break our example. So for now, the only way we can break our example is by commenting out something like schema. Expected 3 arguments found to. God damn it, man. We got snapshots. Let's see. Exploring. Okay, there's the debug print. That should not be there. That's me. And then validation failure for type root error 1, missing or private Ziggy schema decal. This is not the greatest because I think that in the future we will want to report more than just one error. Although these are like, yeah, we can definitely improve dramatically on this. But this is the starting point. So we have error checking and we are able to test this ourselves. By the way, as soon as I'm happy with the testing, I will be able to go to Zine, upgrade the version of Ziggy, and add in the Zine build pipeline a test that guarantees that my types in Zine match what I say on the website. Because on the website, I have not this website. On the website, I have docs that say stuff like, for example, site structure. They tell you, oh, look, this is the zine.ziggy file. This is what you put in a front matter. Somewhere I have a full schema for the front matter. Where did I put this shit? Here, I think, maybe? Front matter. Yeah, look, here I have the full schema. But you know what is sad? This schema is wrong. There are some subtle mistakes. First of all, this is like all very old syntax. But there are some subtle mistakes. Things that I have changed in the official type. And these two guys have gone out of sync. And that's sad. So once this is implemented, I will have build time testing that my types do not lie. So not bad. Let's okay, let's add some let's start adding some actual checking. So let's unfuck this. So now this is correctly passing the initial validation, but this type is wrong. This is wrong. So let's right now, this is essentially a failing test. We're doing DDD now. Sorry, no, TDD. We have a failing test, and our next goal is to pass the failing test. So we have the initial stuff. Arrows land. Whoops. So I think the next thing that we want to do is validate type. I think it's not really idea to put this in a separate function. Maybe. validate type T AST. I mean, yeah. Function validate type Ziggy schema AST void function. Okay. So what are we doing here? Um, let so we need to find. So we know that our type is meant to be the root type of the schema. So we know that we can grab its fields by loading the first entry in scopes, which I think um, it's just scopes at index either 0 or 1. I think 0. Then we just look at the field names and we see that whether they match. By the way, that is a test that we should add in here, right? Actually, you know what? The initial, the simplest test is actually not fucking around with types. It's just getting the field names wrong. I'm gonna add oops to each one of them. Yeah, everything is right except they're all oops. So, field map, well, fields is gonna be ast dot scopes dot get ptr. I think it's at index 0. And then so how do we do this? We can well, the problem is that we need to the full implementation is a full diff, but I'm going for something simpler. So for now, let's just iterate over all the fields. So for actually we want info of t. Oh, we are certain it is a struct, but technically this could also be a union. So we need to switch on this. So for each field name, is it in fields? Okay. So this should recognize fields that do not match. Let's see how we do. For now, I'm just gonna put 8 or else panic. There you go. Validation failed for type root okay. Field root okay dot a does not exist in schema. God fucking damn it. I guess this must be 1 then. No. That surprises me. Is it because it? Oh, because it's the AST node. It's not like a. Okay, so we kind of want the first essentially. We don't really want to do get. We want scopes dot what is it? Items entries. That's scopes. Doon, 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 or like values. Yeah, I guess we want scope values 0, and that means no or else. Badoink. Badoink. That makes sense, actually. So this should be 1 then. Now, I think there's a better way. There we go. Okay, so now this worked, but there's a better way for doing what I just did. Yeah, there's definitely a better way for doing this. Um, there we go. We did it. Validation failure for root error 1. Oops, does not exist in schema. We have the beginnings of this validation. The ST should support getting there is a correct way of doing it. It's me hacking it around. So the way it should work is we need to look at what is the $sign type, and that is defined somewhere in the schema. I don't know the where, or in any case, there is a standard way of doing that. There is a standard way of getting from there. You know what? Resolve Ziggy stuff has it. Schema index 2 is the root expression. Okay. So it seems that this is the magic number. Then what we're supposed to do is grab it from the scope. How does this work? Oh, we tokenize. Yeah, okay, this is not perfect, but it's a good starting point. What am I doing in the scope stuff? There we go. Container index. Yeah, right. Okay, I get what's going on. I'm doing definitely a simplistic approach to this in the schema checker, but it is fine for now. So let's implement the whole field mapping. Also, frankly, whether it's a union or a struct, that should be fine, right? Almost. Now that I think about it, because well, I guess there are options like something like drop unknown fields. I guess you could do that. Okay, these are things, complications that I'm gonna think about later. So I think I'm gonna take a quick break, grab a coke, come back, and let's implement this in a more full-fledged manner. Again, very far from the complete product, but just to make incremental progress. So BRB. Okay, I'm back. Uh, yeah, I lost 2 viewers. That's my fault. I'll never make it big if I keep doing this stuff, like taking breaks. What can I do? To do. This is simplistic. Well, handle schemas that. Well, actually, how do you deal with this kind of stuff? Well, no, you have to do some of that. Okay, handle schemas that don't start from a container type. Then we need to hmm. Um, Technically, now that I think about it, if we were able to build the I guess the compile time, we could really solve everything at compile time. I don't know if that is desirable, but we could. Anyway, so these checks that so let's do it this way. All struct fields are in schema. Then we need kind of the inverse check. We need that to check that all schema fields are in the struct. And there are probably more sophisticated ways of pulling this off, but we can do it in the simple way, which is for scope dot fields dot keys. Oh, wait a second. No, we cannot do this. We cannot in line 4. We cannot use metaprogramming to check the field. Um, huh. Hmm. We could make a hash map of the struct field names that will be available to us at runtime. Static string map. Init com time. Shit, there's the super ass crappy com time init function. Oh, or a list of God fucking damn it. This is even worse now after the changes to metaprogramming. Init enum. Init enum? Oh, this is with extra steps, but it might be convenient. This is with a. Also, wait a second. Where's the argument? V must be an enum. The enum stack names will be used as keys. Oh. Okay, what is available to us in meta then? We can make it a field enum. So we could do it like this. And then this is so dumb, but it works. So now I have a map of all struct fields, and then for each uh, schema f name, I can do if not. If not, struct fields contains also wait. Is this init enum failable? No. Okay, as it should. Not contains schema f name. Fatal t schema field missing from struct definition. Okay, so now we have the other checking. Let's see if this is so here we have this. I think this should not be fatal. I think we you know what? I think we are very quickly approaching the territory where we just want to collect these errors without instantly failing. Um yeah, so let's add root error 2. Oops. Actually, this is more like a root error 3 or you know what? We can have an even simpler problem. So here there's only A and B. Here there is, so this is error 1. Then error 2 has error 2 has C, but then it also has D. So one has one fewer field. This one has one too many fields. You know what? Actually, we can even simplify it even further. 2 fields. Then this one has only one. This one has 3. This one has a field that is correct. one that is wrong. So this has both a field that is wrong and essentially a missing field at the same time. Okay, so far so good. Yeah, let's change this from fatal to something more sophisticated. Okay, so we don't want to die immediately when reporting errors. So we don't want, I guess we don't want this to be fatal. We want something more like continue. So doesn't have Ziggy. So maybe we can keep fatal as fatal. I don't know. I think we just want error. I guess the question is the error rooted in the schema or in the type? Which from which perspective do we present the errors? From the type, because this is a type of tooling where we consider the schema to be authoritative. It might not be necessarily the case, but that should be our default stance. So okay, so the signature should be kind of the same. Um, but I think we want one type. Do we also want an optional field? Print the type name, print dot field if there is a field. Regardless, after that, print a colon. Print a colon space, and then we print fmt arguments and new line. And you know what? I think this should be something like a struct that collects some state so that we can then test whether this guy was invoked or not. So const error. So that means that we're going to call error the type. What do we call the function then? Hmm, report. Okay, an error has a state, which is any error, any starts at false. There we go. And so up here we do error equals It could be a report error or report warning. So we could change this to report. We do r.r. Yeah. It's fine. R.report. That's fine. Okay, so this becomes r.report. The type T is missing for private Ziggin. We continue. Same down here with schema. So these two have to be present. Then we also want to do the same in case that we encounter an AST error, but here's where things get funky. This is runtime sheet. So that needs to be moved to a function. Everything else needs to be moved to a function. Although, you know what? We could, it's essentially validate type that we're doing here. We're just starting early. So we can move this here and it works. You don't accept AST as input. You just take T and arena. Yeah. So this guy can go. How can I fall in love with dev coding? Maybe I have to do some beginner stuff up or something like that. How can you fall in love with dev coding? Huh, good question. I don't know. I kind of had it since I was a kid, essentially. So it's hard for me to pinpoint the reasons. Uh, I guess on one end, you need to have an appreciation for machines in general. Like you need to like machines because these things are machines that you are making do that can do things, and you need to somehow, at least to some degree, be happy when you see those machines do things that you want them to do. Then past that, I think that you need to be opinionated and have, in a sense, developed a good taste for uh, what you believe to be good uh, patterns, like good things that the computer makes users do, and and I would say, also conversely, at the same time, in a sense, also have an appreciation for the things that you consider to be bad or just not optimal. So, for example, I don't know, um, you spent your whole life using chat applications that work a certain way, and then you have become an opinionated users when you really think that the chat application should work in a different way when it comes to something important. One example: there used to be a time where chat applications did not have the concept of read receipts, and somebody who was opinionated about this stuff said, "Man, you know what? I would like to be notified when the other side has seen the message, even if they don't reply actively to me. Because if the only way to acknowledge that the other side has seen a message is for them to respond, this leads to an endless ping pong, right? Because they write to me to acknowledge that they have received their message, and I write to them to acknowledge their acknowledgement. I mean, in reality, you do stop at some point, obviously, but it forces people to type more than maybe they would want. So you could say, I'm gonna add the scene check marks, and yeah, that is something that does something. But conversely, you could also say that maybe the opposite is true. The scene checkmark is detrimental because then the other side knows when you've seen the message. So now you cannot take a look at the message without telling other people that you have seen the message. And so it's like an engagement driving thing. So you form nuanced opinions around this stuff, and then you build up all the technical knowledge necessary to make your vision come true, because the reality is that without the technical knowledge, your your mental model of how things should work is always going to be imprecise and unrealistic. And actually, even if you do have the technical knowledge, your understanding of how things work will still be unrealistic until you actually do it firsthand. So I don't know, that's kind of the idea, I think. Okay, let's you know what? Let's comment these guys out. Let's assume that we don't use them anymore at all. So, um Ziggy giving us problems. We just return, I guess, at this point. Then here this becomes, oh, we need to pass down error also. Also, this cannot be as edited by print. This needs to be error report. Oh, this one's a schema. This one's to print a schema error though. And I kind of like this. The problem is that I don't have a way of doing this. But we can do report schema. Okay. There we go. Frankly, a report schema could be even made simpler. We just pass in the errors and that's it. Like this. Yeah. Why is this currently on the function? Okay. Okay, report schema looks good. Hmm. Okay, so let's see. Build errors, and then we should have done the change that we wanted to make. Almost. At the end, we want to do this. If actually std process.exit int from bool. Hey Matt, bruh, why are you brahing? What's there for you to do, bruh? Boom. Check this out. That is so nice. 70 months. Yeah. We're almost we're getting close to having 10 kids together, huh? Back to back, of course. No rest time. Expected type check error found const. Fuck. Of course. Italian style. What is the problem here? No field of manager contains in string map static string map. What? A static string map does not have contains? There's has. Oh no. API is going out of sync, man. What a mess. Two unused arguments in does not exist in schema. True. There we go. Okay. Schema field C missing from struct definition. Right, I need to update the schema as well. Okay, let's rerun the checker. Okay, ignore the debug printing. That is not relevant. Schema field B is missing from struct definition in error 1. Yes. Actually, maybe this should also be presented as root error 1 dot root error 2 C does not exist in schema. Root error 3 B ops does not exist in schema. Schema field B missing from struct definition. Yeah. So this is good. We need one that contains a schema error also. So let's add another test case. We're gonna copy schema and make it a schema error. Schema errors. So the idea is we take the schema and we take out a comma here. Take out a comma. What else do we do? Oh, it only reports one error at a time, does it? Okay, let's see what happens now. Bro, where's my other test? Where's my other test though? It's above here. Okay. Root, okay, Ziggy schema, missing comma after field. That is delightful. Okay, there we go. It was up here. So this is delightful. I'll take this. That is pretty good. So we have the super basics. We recognize struct fields that don't match. We don't understand default values. We don't understand unions. We don't understand schemas where the top level is not a struct or a container type. But hey, one step at a time, I guess. So we need to do this. We can do types. So we need to do types. We do it here, I think. The type checking should be that the field exists. So instead of contains, we can do get. And then we need to check that the type matches. We do get. Uh, what's in a scope field? I don't remember how this stuff works precisely. What's in a scope field? What's the value of a scope? It's an index. I guess it's a node index that corresponds to the field node. So we need then to look at the value. So if it has a child, we have nodes. Actually, yeah, no, I'm not even sure if this guy is supposed to have a child or not. I guess we can look at an example. Yeah, when we are in a start field, how does it work? Container fields, container decals. Okay, start field consumes a token. Analyze. Mm, consume the column. Okay, so it does add a child to the field that contains the type expression. And the other cases are just mistakes. Okay, so we look at the field, we look at the child, and then the child needs to be essentially tokenized because the child is going to be a type expression. And then the type expression needs to be matched. Also, we need to recognize loops. We need, like, if we start following like struct names, a struct could very well contain an array of itself if it wants to. And yeah, that's a testing loop. So we need to recognize that, and we need to essentially say okay. So we need like a stack of things that we have already visited. Oh man, so much work. Okay. So much work. Okay, now I get how this stuff works though. For now, we can add like the simple type expression checking. Field node, and then in the field node, we look at the first child. How do you do that? I think you need to do +1 and test if it's itself. Parent, I mean. Yeah, it has next index. Okay. Actually, we can, if we got here, we know that it is there. So we can assert, but the child index has to be there. And actually, we don't even need to grab this node because we don't have anything to do with it. So we don't even care about it. So child IADX is this one, and then we do validate type expression. We wanna pass T. Um, we don't need arena. Do we need arena? We do not need arena. We need error. We need AST. Oh, probably we do need. We will need arena. Well, for now we don't. Mm-mm-mm-mm. So type AST index. We need error. Okay, so the child is gonna be AST. Let's call it type expert. AC nodes IDX. Actually, what else is in a node? Tag. We can assert, and then um, I guess we can slice it. T.ziggy.schema. So now we have the text. And in theory, what we should do is tokenize it, I guess. We need to tokenize it. There's no init. Okay. So next slice. Or else panic. Well, no, it has to be there. So dot question mark. It's guaranteed to be there at least once. So for now, we just grab one token, and then for simplicity, we'll leave that as it to do. So switch talk dot tag. So what could we have found? If it's bytes. Oh, here's a problem. Yeah, that is the delightful that we're validating this type expression, but right now our t our t is not enough. We also need the field that we are at. We need to see the field that we're at. We probably want the field name so that we can report errors, but we want the field type, I think, more than anything else. I guess we can do s.field types. Okay. You know what? I think we essentially want to print this no matter what. So I think this goes below here, and essentially we just have an early return when on success. So this is the for bytes. For int, I this should be better. And it should be a switch for int. What else do we have? Bool. Do for bool. Bytes bool. Float. Okay, so these guys are fine. Technically, these above also could be made better, but for integer it's really strongly necessary. So if the token is not int, we switch type info of type. No, we don't switch type info. We say, we look at the case, right? If type info of f type is different than dot, I think it's integer, or actually, if it's equal, then we return. So there you go. Okay. Otherwise, we report the error and then we return. This should be doing validation with, let's say, else panic to do SCD bug panic. Panic with A to do. Okay, let's see how we build. Incompatible types. Struct something something. What? Struct something something. Struct and com time int. Oh, but that gives me an entry. Uh, get value PTR or something like that. I don't remember. So get value PTR, get value. Actually, you don't need PTR. I just need to get value. There's no get value, really? Get or put, get entry, get index. Wait, oh, that's me fucking it up. Scopes does not contain. Scopes contains a struct that then contains index. Oh my god. Okay. Destination pointer requires an alternation. Understandable. Expected optional type found token. Oh, so it does not return now. I don't know why I thought it would. Has no member named Bytes. Oh, because it's Bytes KW. These are all keywords. I might have got them wrong int KW. No, I got wrong integer. Is it just int? Invalid from a string T for a string. Okay, so these are the things that we did before. They keep working. That is cool. Let's move simple into type errors. Actually, type errors is wrong. Types. So Ziggy schema as bool and int. Okay, in our root.zig, bool and i32. Set another few okay ones. Bool and i64. Then error is going to be b is a string. Okay, so void. Actually, void is complicated. Let's not do that. Okay. I mean, that's kind of it essentially. U32, U32. Bool, U32. U64, and then both wrong. Okay. There we go. Erdo.a has type consuate, which is incompatible with bool keyword. Oh no. Is there anything better, please? The tokenizer. Tell me that you have like lexeme is expert. It has lexeme. Okay, let's call lexeme. It's compatible with bool. Has type blah blah blah, which is incompatible with bool. Consuate, which is incompatible with int. Wait a second. So these are all error. I don't see root error 1. Where's root error 1? Oh shit, error 1 is actually okay. That's wrong. Oh, I see what's going on. Okay, that's kind of here. Optional. Yeah, so this is 1. This is 2, and the other one is 3. Okay. Yes. 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 Nice. So, we have some good old schema checking going, and we also check types. We are covering, I don't know, a tiny fraction of all the things that we should cover. But yeah. So this is actually making me happy. This already is pretty good. Pretty good. Pretty good. About a bajillion to dos still left, but yeah. Well, I already have these to do left here, so yeah, that's not bad. Okay, what do I want to do next? I don't know. This was a good push. I don't feel like doing all the work to, methodically figure this all out. I think I want to take it easy, bit at a time. I'm delighted that my experiment is panning out because the basics are there and they really seem sound. Like I can totally see myself running this in Zine. So in Zine, I have page, for example, and page, this is the front matter. This is my type for the front matter, and some of it matches, some of it doesn't. So we need this needs to be sorted out, and I have fields that I skip that are considered private, essentially. Yeah. Do we have our own rendering function by any chance? No, we don't, because it would be inside of Zig options, I think. Yeah. So this is all well and good, essentially. This is a awesome starting point. Really wanted to combine telecasting with Zine for Matter. Oh, I don't know what's telecasting. What's telecasting? Working with Markdown. Oh, is that telecasting or Markdown? I mean, yeah, it was kind of in the name. Holy shit. What? I didn't notice. Oh yeah, because it's under an organization NVIDIA telecasting. Okay, so that wow, I didn't know. Okay, yeah, I'm happy with this. I'm happy with the progress made. I think, yeah, I think you know what? It's Saturday. I'm not gonna overdo it. 3 hour and a half long stream. That is okay. Made some progress. As this experiment is right now in terms of completeness, it is already useful for Zine. Like I could totally take these as is and make the switch. It would be almost good enough. I mean, I would have to fill out a few things that I'm missing, but that would essentially be it already. Nice. I guess the next stage is going to be figuring out the LSP stuff for Zine, because I would like for the system to kinda pick the stuff. Oh no, I have a solution for it. Yeah, I do have a solution for it. Kinda. Anyway, well, everybody, I hope you had a good time, and I think I will see you next time. We did it. We made some good old type checking. What else can I say? This is nice. I'm gonna add. Well, I need to turn off this debugging stuff. Maybe we should make this executable non-debug. It's gonna take it longer though to build. That is annoying. Oh, blah 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 blah. I think I should have a thing that turns off scopes even if you're in debug, and by default they're all turned off or something like that. I don't know. But we can solve this. One way of solving this is removing the print, exploring top level type 3. So that we don't pollute our snapshot tests. Yeah. Yep. 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 Nice. Okay, so this was a success. Everybody, I hope you had a good time. And I think I'm gonna call it here. I'm also gonna be lazy and I'm not gonna raid anybody. So yeah, you are released from the chains and you're free to go do whatever you want with your